Assalamu alaikum, dear students. In this lecture, we will be solving some examples and exercises on the basis of properties of determinants. As we have learned earlier in the last lecture, uh, what are determinants and the properties related to determinants. Now we will be evaluating some exercises. For example, we have say example number uh, of example number 8 is here. We want to evaluate this. We can expand this along any row or column. So how to expand? For example, we will evaluate it, we will expand it along the first row. Along the first row we will be expanding this. So this is 3 times this subdeterminant. Three times it's 2 3 2 3, so it's like this. And then their multiplication is 3 to 6, 2 3 6 minus times minus next element, that's minus 2, then its subdeterminant suppressing its row and column. We will suppress this second row and second column and this first row. We will get here 3 to 6 minus 339, so it is here. Next is 3 times it's this subdeterminant, so it is 2232. Yes, I'm talking about these two entries and these two entries. So it's 224 326, so it's this. We will calculate these, so that its value is equal to 0. We have actually expanded it as without using the properties, but this is actually this confirms the property that we have studied earlier, because it is first row and it is third row of the determinant, they are same, and we expect its value to be equal to 0. Yes, that is okay. We will come to some exercises here. These are exercises in exercise 4.2. Question number 1 is, the heading for the question 1 to 7 is using the property of determinants and without expanding. In exercise 1 to 7, prove that. We have to prove this is equal to 0. In order to evaluate this, we have here, we will be solving this like this. It's x, y, z, a, b, c, x plus a, y plus b, z plus c. So the determinant is written like this, as we have read in the property that if we have any row or any column, the elements of that row or that column are expressed as the sum of two elements, for example, like here, then we can break the parent determinant, this whole determinant, in the two determinants, keeping these two columns same in both the determinants and writing the column 3 in the first determinant as xyz and in the second as abc. So we have written like this. So we actually break the determinant in two determinants. So you see, in the first determinant here, it is xyz, it's xyz here, so its value is equal to 0. And here it's ABC, it's ABC. Its two columns are identical, so its value is also equal to 0. So it is 0 plus 0, that's equal to 0. So this way, we have solved this determinant by using properties, not manually solving. Question number 2 is using the property of the determinants and prove that this is equal to this. So here it is solved. You can see this. So you can see from the properties of the determinants, I've solved it here. You can see this from this. Question number 3, using the property of determinants without expanding, prove that this is equal to 0. On the same lines, we can do it. We have I have break it here. Sorry. Yes, I have broken the column third here in two columns. This and this then expanded accordingly. So this its value is equal to 0. Question number 4 is it's 111 BCCA and it's AB A into B plus C, B into C plus A, C into A plus B. We have to prove this is equal to 0. Very simple. It's not any hard task to do. So this is this starting of the solution. What we will do, we will add column 3. We will write column 3 as column 3 plus column 2. We will add column 2 to column 3. We will get here AB plus BC plus C, AB plus BC plus C, AB plus BC plus C. We will take this AB plus BC plus CA common. We will get 111 in the first column, and we will get 111 in the last column. You can see that first column and last column are proportional, so its value is equal to 0. Next one is question number 5. On the same lines, breaking the determinant into different determinants, so we can prove that its value is equal to the required value. Okay. Now the next question is question number 6. By using the property, we have to show that this is equal to 0. So how we can do this? Here is the solution. This is the determinant. We will be applying the property R1 changes to C times R1. So this is like this. And the same quantity we have to divide in order to neutralize the value of the determinant. You can see after operating these steps that it is B, it is B, it is C here, it is C here. 0 here, it is 0 here. So its value is equal to 0 because R1 and R3 are identical. Question number 7. We have to prove this is equal to 4 times A square plus B square plus C square. See here. In this determinant, you can see the first row of the determinant is minus A square AB AC. So we can take A common. From the second, we can take B common. From the third row, we can take C common. So we have A, B, C out as it is like this. As I'm talking about this step, we have taken A, B, C common. So on the same lines, we can take now this A common. We can take this B common. We can take this C common. Already there are A, B, C common. So once again, we are taking A, B, and C common. So it's A square, B square, C square. What remains inside, that is 1, 1, 1, and they are positive and negative signs. Now we can apply the property, applying R2 changes to R2 plus R1. So it's like this. Then after using the simple expansion at the last step, so it is 0 into 0, that is 0. 2 2s are, that's minus 4. So you get 4 times A square plus B square plus C square. Question number 8. You can solve it. You please see this. And this is question number 9. By using the properties of the determinants, we have to solve this. It's again same. Please follow these steps. You can solve this question as well. After that, it is question number 10. By using the show that this is equal to this. Please follow these steps in order to solve this question. Okay. Yes, we can. Okay. So all these questions are based on the properties of the determinants. So in this lecture, we will be stopping here at question number 10. I hope that you have got all these questions, and there are some exercises that are left for as home assignment for you. For if there is any problem in solving these questions and the evaluation of any matrix, you may put your queries in the comment box. I will be more than happy to answer your queries. Thank you for joining the class.